Okay, let's take a look at doing the actual hypothesis test in Excel. And what we're really looking to do is we're looking to compare two groups and see if they're statistically equal. Now, two things might be equal and they might be statistically equal, which is a different thing. To see if two values are equal, obviously we look to see if one is equal to the other. To see if things are statistically equal, we look to see if they really are close enough to be considered the same value, or if they're too far apart that there's too much room for error and they're not the same. So the first thing we do want to take a look at is how do we sort this data out to make it ready to test? What we're going to focus on testing in this vet data is knowing if the cost for the vet visit is the same for males and females. And just like we talked about before, setting up the written portion or the typing of the math, now we're going to look at how to do the actual statistics. The first thing I do need is I need all the costs for the males in one column and all the costs for the females in another column. This is easy to accomplish by doing a sort on the data. And I can highlight the data and go to my data tab, and what I want to do is I want to sort. And I do want to sort it by gender, because I do want, and it will pull down a drop-down menu. You can choose any of the columns you have in the data set. I'm going to choose gender, because what I do want is all my male data grouped together and all my female data grouped together. And what this does is it does sort out so that all of the male data is on top, because they were the lower number, and all of the female data is on the bottom. And the easiest way to deal with this is to do a quick copy and paste, and a copy and a paste. Now, it's important to know we don't need the same amount of data for each column. It's okay that the female data is longer, as long as we do have it sorted correctly so that we do make sure that nobody is included in two groups. Oftentimes, a common error is one of the border groups if I accidentally highlighted the 40 twice and put it with the female data. So we just want to do a double check and make sure that we did highlight and copy and paste everything correctly. The next thing we're going to do is we're going to use Excel to do a hypothesis test for us. Okay, now what we're going to look at is at the very bottom, what we want to look at is a t-test, two sample assuming unequal variances. This is at the bottom of our data analysis tool pack. So I'm going to choose t-test, two sample assuming unequal variances. It's actually very rare that the variances are equal, and I'll choose OK. It's going to ask me for just a couple pieces of information. It's going to ask me to highlight my first column and then my second column. Order is not important, so it is not important which one is variable 1, which one is variable 2. What is the hypothesized mean difference? What do I think the difference is? For the most part, we think the difference is 0, or we think that the two are the same. Occasionally, we might think that, maybe males are greater than by $10 or $20, so we might have a specific value in mind, but for the most part, we're going to stick with 0. And I'm just going to highlight the labels box, so that I know that I did highlight the labels when I did my highlighting. Alpha is the level of error that you can adjust to your preference, but we're going to leave it at 0.05. Okay. What we have here is, I'm just expanding the columns a little bit so you can read. Some summary information at top. What is the average for each group? The variance, how many observations for each group? And then we're going to look at a couple different statistics. The t-stat is the statistic or the test statistic for this particular data, which we will then compare to either the one-tailed critical t-value or the two-tailed critical t-value, as we discussed in the live chat. The p-value is calculated for the one-tailed or the two-tailed option, and you do have to be careful in that you do read that correctly as to which tail it belongs to, and that is compared to our alpha level, or 0.05, and this is actually the value that's more frequently used than the test statistic. And the important thing to keep in mind is if P is greater than alpha, we fail to reject our null hypothesis. If P is smaller than alpha, we reject our null hypothesis. So in this case, if we were going to do a two-tailed test and say, well, are they equal or not equal, I would notice that P is bigger, the P value is bigger than the alpha value, which means we cannot reject our null hypothesis. If it had been a smaller value, we would reject our null hypothesis and say that the data supported all our alternative value. Now what you do want to do is make sure you copy the entire output here. You can actually copy and paste that right into your project for your Microsoft Word document that you're presenting this week.